So we do have the same learning goal as yesterday, except that what happens when we're solving systems of equations and using the elimination method, they aren't also, just magically set up so that you have opposite x terms or you have opposite y terms. So sometimes you're going to need to rename one of the equations before you can add them together. So you can't just go straight to adding them together. Because again, remember, we need one of the variable terms, either the x's or the y's, to eliminate. So if there are not opposite x terms or there are not opposite y terms, we have to kind of basically make it happen. So it's kind of like when I've told you before, when we have like equations that have decimals in it, you have to solve a decimal equation. So a good example would be that one just the other, like on that assignment, I just handed back to you. No, that was the day before, the 81. Remember the 5% account, amount of money invested in the 5% account and then the 6% account, and then all together they took in $58 interest? You could have made that problem a whole lot easier for yourself by, after you did that, you could rename that equation by getting rid of those decimals. So what would you have to multiply every piece of that equation by to make it friendlier? Like 100. So if you took every piece times 100, now you'd have a 5x plus a 6y equals 5,800, and it would have been probably friendlier to work with. Same thing goes here. As long as we do that, whatever we rename, as long as we do it to every piece of the equation, we can get away with renaming it. So that's what we're going to do. We're going to multiply one of our equations by a value that will create those opposite x terms or y terms. And you get to decide, which one do you want to rename? How do you want to rename it? What are you going to multiply by to make that happen? So let's look at our first one here. Do we have currently opposite x terms? No. Now, if you were sloppy about this, you might just put an addition sign there and put an addition bar there and say, well, the 2 and 2, they'll cancel each other out. And then you go to work solving it and you get this, this nice solution for y. In fact, I worked it out. You would get a nice integer value for y, and you'd be convinced that you're on the right track, and you'd keep going. But 2x and 2x are not opposites, are they? So how about the y terms? Are they opposites? Yes. Y and 1y and negative 5y, are they opposites? No. So we need to rename one of them. So we can either create opposite x terms or we can create opposite y terms. I'm telling you I want us to create opposite x terms. So I want to teach you right away that, make your life as easy as possible. So Corey, what could I do? Multiply by negative 1, because then that will take that 2x in that equation and turn it into a negative 2x, which will then be an opposite to that other one that has a positive 2x, right? So what we're going to do is our first thing is going to be rename. So we're going to rename, and we're going to take, not 2, excuse me. We're going to take that negative 1, and we're going to take it times the 2x minus 5y. I'm putting it in parentheses because I'm going to do it as distributive property. Or you could just give each of those terms their own factor of negative 1. You could say negative 1, because that's really what we're going to end up doing anyway. I would change this to add the opposite. And I'm really going to take negative 1 times negative 5y. So that's really what would happen anyway, wouldn't it? And then we have to make sure we do it to every piece, both sides. So we have to make sure we also multiply that 13 times a negative 1. So either way, every piece has to get multiplied by that negative 1. Here's where you will typically, if you find that your answers aren't checking out, here's where it will typically go wrong for students. You remember to multiply the one side of the equation, and you forget about the other side. You would forget to multiply that 13 by that negative 1, and then that would keep it a positive 13, which would change the whole thing up. Okay, so just make sure you multiply every piece. So what's this equation's new name? Negative 2x plus 5y equals negative 13. Now it is ready to be added. So here's our first equation. and our newly named second equation. Now we can set up our addition problem and do exactly what we did yesterday. Add them together. One of our terms should eliminate. In our case, we were trying to get the x's to, and they do. So now we'll solve this equation for y. So what's our y value? -3. And we need our x value yet. Now, you have 3 options now, really. Not that it's, any of them are going to be necessarily one any better than the other, but you have the first equation we did not rename. You have the second equation's old name, and the second equation's new name. You can use any of those 3 equations to go get your x value. So pick the one you want to use. I'm going to use the first one. Seems to have the least going on in it. Now I get -1 for x. Agree with me? So we are, at this point, we believe the ordered pair solution is what? -1, -3. Okay? What are we going to do now? Yeah, we are going to do check problems again today. So let's go ahead and do our check problem for this one. So now, this is where you must check them in both original names. Not that new, second equation's new name. You can't use that because if you renamed it incorrectly, of course it's going to check out. So you need to check in the original names, which are 2x plus y equals -5, and the other one is 2x minus 5y equals 13. Subbing in your -1 for x and your -3 for y. I'm seeing some kind of crazy check problems on some papers. It's like the values that we find for the variable are not replacing the variable. The variable kind of like hangs out with it, comes along with it. It's replacing. So we want to make sure that that's what we're doing, is we're substituting in, and there should no longer be x's and y's in our checking after we in that substitution step or beyond. I cannot get that to look like just a normal addition sign. And when you're working down, like on this side, as you're working down, you should not even be looking on that other side to see, this is what I need it to be. You should be seeing what is actually happening. So maybe you don't even want to bring down that other side until you actually get this done, and then you can say, oh, okay, I got this coming along. Now I'm not tempted to fudge and say it really does check out. Because again, that's what I'm seeing on papers also. Somehow or other, -20 plus 2 magically is a positive 18. Because that's what you want it to be. But it's really a -18, that means it's not checking. Any questions? Okay, we're going to just do one more together, and the only together part we're going to do, though, is talking about what do you think are some of the options we have here for renaming. So, Austin, what's one option we would have?
Multiply by -2.
Okay, so if we multiply by -2, you're going to say what's going to get multiplied by -2? Which equation?
The second one.
The second one. And so Austin, your goal in multiplying the second equation by -2 is to create what? Cancel the y's, to get the y's to be opposites. So we could multiply this one by -2. That's one option. Or what's another option we could do? If we multiply what by +3? The first one by +3, our goal then would be to do what? What's that going to do for us? Get rid of the x's it would create. So we're going to put an or here. We have two options. You're not going to do both of them. You do not want both of them to cancel out. Well, trust me, they wouldn't anyway. You would just create new names that still would not have opposites, and you'd be frustrated. So you have multiply the top one by 3, multiply the bottom one by -2. You pick which one you're going to do and do it now. Go. And then when you're done renaming it, look up here to see if you renamed it correctly. Okay, so you have one or the other of those. You either have, the first one as a new name is 3x plus 6y equals 33. You agree with me? Anybody do that one? Yeah, okay. Or you have the second one you renamed by multiplying by -2, and you should have 6x plus -2y equals 10. Anybody do that one? And you agree with me? Okay, now you go decide which one. Okay, not decide. You already have one of them. So basically, I renamed the first one in this column, so I am going to need to add that one to the other one. Don't add it back to its old name. That's not going to get you anywhere. So that would happen here. Over here, since I renamed the second one, I would leave my first one, x plus 2y equals 11, and add the new name, second one, to it. So you're doing one of those addition problems or the other. After you get your x or your y value, depending on which one you're doing, that will determine which value you'll get first. Go back and find your other variable. And then I'm only going to find them. I'm going to do both of these because we should still agree anyway. So again, my work's going to be a little bit different than yours because I did both of the additions instead. But either way, I'm going to get the x and the y. You had to go back and, after you got your x, you had to go back and substitute to get the y. Or if you got the y first, you had to go back and substitute to get the x. Do we agree? Okay, let's do our check problem. Where do we check it? In the original name. No new names can be used here. You cannot check in your name, rename them, because guess what? You will rename them wrong sometimes, and you're going to be mad when you got the wrong solution, but yet it checked out for you. You'll be like, wait a minute, but it checked. Yeah, because you had the wrong, you solved the one that had a different name, and that it will check out. and it should check out mine didn't pay out. Yours? So just a little bit more complication, but it's still pretty easy to do when they're in standard form. Much easier than having to use the substitution method, isn't it? Okay, anybody have any questions? Okay, let's write down the ones you're doing. You have 10 problems to do today with check problems.